Hello everyone, and today here are our objectives. The first thing is we will review how to get class mark, relative frequency, class boundaries, and cumulative frequency. The second one will be we will be presenting the data through histogram manually and using Excel if we still have time. What is class midpoint? The point halfway between the upper and lower limit of a class. The class midpoint is computed by adding the lower limit of consecutive classes and dividing the result by 2. And please don't forget, class midpoint is also called as class mark. And how to get class mark or class midpoint? So we're done with this already, but for you to remember how, I want you to look at the first example here. CM stands for class mark or class midpoint. And to get class midpoint, I want you to look at the lower limit here and the upper limit. The formula is simply add lower limit and the upper limit and divide it by 2. So that will be 9 plus 17 equals 26. Divide by 2 is 13. That's why the first class midpoint of the first class limit is 13. How about the class midpoint of the second class category or class interval? This is 22. So how do we get 22? So let us apply the formula. Lower limit plus the upper limit divided by 2, and that is 18 plus 26 equals 44. Divided by 2 is 22. Okay? And how about 31? 31. That is 27, your lower limit. 35 is your upper limit, and when you add that, that is 62. Divided by 2 is 31. Now, there is a technique on how you find the class midpoint. You don't need to add each lower limit and upper limit and divide by 2, but just simply add the interval to the first class midpoint. At first, our class interval, I want you to look at the difference between the two. 18 minus 9 is 9. 27 minus 18 is 9, and so on. 26 minus 17 is 9. 35 minus 26 is 9. So our interval is 9. It says here, just add the interval to the first class midpoint. So this will be 13 plus 9 is 22. 22 plus 9 is 31. 31 plus 9 is 40. 40 plus 9 is 49. Plus 9 is 58. Plus 9 is 67. So that is the short way. But if you want to add the lower limit and the upper limit and divide by 2 to find the class midpoint, that is fine. Next, how about the relative frequency distribution? It says here, it is often helpful to know what percent the class frequencies are of the total of observations. Relative class frequency shows what percent each class is of the total of observations or frequencies. In short, this is found by dividing each class frequencies by the total number of frequency. That is very simple. So let's have an example on how to get the relative frequency distribution. Using the same table, this is our class limit, tally, the frequency, and relative frequency. So as you can see, this is relative, and we're talking about frequency, and the formula is very simple. Divide each frequency by the total, and I want you to express your answer in percent, so you need to multiply the answer by 100. So let's have the first. The first class limit frequency is 1 and the total is 30. So 1 divided by 30 times 100 is equal to 3.33%. I want you to limit your decimal places until 2. Next, how do we get 33.33? That is very simple. It's only 10 divided by the total times 100 is 33.33%. Next, how about 26.66? That is 8 divided by 30 times 100 is 26.66. Then 16.66, we got that from 5 divided by 30 times 100 is 16.66. And for this, since they have the same frequency, that is 2 divided by 30 times 100 equals 6.66%. So that is a very simple percentage. Divide the frequency by the total, and if you want to express it in percent form, just multiply it by 100. How about the class boundaries? To get the class boundaries, I want you to use the same table. The formula is simply lower limit minus 0.5 and upper limit plus 0.5. So this is our lower limit, 9, and the upper limit is 17. So to get 8.5 up to 17.5, simply subtract 0.5 from 9, and that is 8.5. Then add 0.5 by 17 and equals 17.5. And for the second one, 18 minus 0.5 and 26 plus 0.5 is this. Next, 27 minus 0.5 is 26. 35 plus 0.5 is 35.5, and so on. And the reason why we are getting each part of the table is because we need this in presenting this data graphically. Okay? So the last part of the frequency distribution that I want you to look at is the cumulative frequency. If you will look at the definition or synonymous term of cumulative frequency, that is increasing or a successive addition. So meaning, in finding or getting cumulative frequency, we will just add it from the start up to the end. To obtain this, start from the first frequency, then add the next frequency successively. Using the same table, okay, we will start from the first frequency, which is 1. That is where we will start. And add the next frequency, that is 1 plus 10 is equal to 11. Next, 11 plus 8 equals 19. Next, 19 plus 5 equals 24. 24 plus 2 equals 26. 26 plus 2 equals 28. And lastly, 28 plus 2 equals 30. And don't forget that the total sample or total frequency must be equal to the last cumulative frequency. And now, let us have the importance of graphical presentation. Statistical graphs can be used to describe the data set or to analyze it. Graphs are also useful in getting the audience's attention in a publication or a speaking presentation. They can be used to discuss an issue, reinforce a critical point, or summarize a data set. They can also be used to discover a trend or pattern in a situation over a period of time. Now, there are different graphical presentations that we can use in organizing and presenting data so that we could describe it meaningfully. But the first one will be histogram. And histogram is like a bar chart, but the difference is histogram is a touching bar chart. This is a graph in which the classes are marked on the horizontal axis and the class frequencies on the vertical axis. The x-axis, you can use either class boundaries or midpoint or class midpoint. But the y-axis is your frequency or the dependent variable. Please don't forget that this graph has no gaps, no space. So in constructing a frequency histogram, we will use class boundaries and the frequency. So what will be our x? Your x will be the class boundary and your frequency will be your y. So let's plot the class boundary and the frequency. By the way, if you want to use the class midpoint or the class mark, that is fine. The very first thing and the most important part is to label each part. Of course, we need to put a title. The title is really very important because it don't make sense if there's no title. So you can start with histogram of. So whatever title you may have, or if that data is all about weight, just put histogram of weight of 30 people and so on. Just don't forget to put the title. Next, on the x-axis, we need to label it class boundaries, and on the y-axis, let's put frequency. So again, we can make use of the class midpoint or the class mark, but let's use the class boundary first. Now, what is the lowest class boundary? The lowest class boundary is 8.5. So let's put 8.5 here. Next is 17.5. After that, 26.5. By the way, this is 0.5. Next is 35.5, 44.5, 53.5, 62.5, and lastly, 71.5. Now, I want you to look at the frequency. The lowest is 1 and the highest is 10. So if you want to make an interval of 1, 2, 3 up to 10, that is fine. But if you want to use like 2, 4, 6, 8, 10 for as long as the interval is consistent, but I prefer an interval of 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, I want you to look at each class boundary. Class boundary from 8.5 to 17.5 has how many respondents? 1. So 1 is here. So that will be from 8.5 to 17.5. Meaning to say that the class boundary from 8.5 to 17.5 has 1. Next, how about from 17.5 to 26.5? There are 10. So, please remember that histogram has no space, has no gaps in between bars. So, there are 10 respondents fall from 17.5 to 26.5. Next, from 26.5 to 35.5, there are 8. So 8 is here. So from 26 up to 35.5. Then we have 35.5 to 44. there are 5. Then there are 2, also 2, and there are 2 as well. If you want to put the number here or the frequency here, 1, 10, 8, 5, 2, 2, and 2, it's up to you. And then if you want to put some color for you to see the difference, it's up to you. But the proper graphing is more important, and a complete label of this graph is best. So, given this data, we have class limit with frequency and class boundary. This is the histogram with title, with label. The graphs has no gaps and no space. So we will continue presenting the graphical presentation by tomorrow. So this is it. If you have any question, you can comment down below. And if you think and you feel that this video is informative and help you, please consider yourselves subscribe. Don't forget to like, comment, and share on this video. Thank you for watching, and thank you for learning with me statistics. Have a good one.